Let us talk on the inheritance. We are going to study how Python support inheritance feature and the types of inheritance and some example. Okay. So if let's talk theoretically, what do we mean by inheritance? So first things, inheritance is the fundamental concept in the object-oriented programming, and Python support object-oriented programming. So inheritance, uh, or the feature also supported in the Python. So if talk about the inheritance, that means it's allow a class to inherit attributes and methods from another class. So here we have a one existing class. Let's say we have a one class. They have a defined some attribute. They have a defined some method. Okay, some method, and now we are going to build create another class, and here I want to use the same kind of attributes or same kind of method in this class. Generally we are going to write again the attributes, again define the methods and use them. So inheritance say why you are going to write again the attributes and the methods that already exist in the separate classes. Why not just inherit it? So inheritance tells us, hey, if we have any existing classes that have already defined some attribute, some method, so if you are going to define new classes and in this class you want to access, just use the inheritance. Inheritance allow these attributes and methods are available in new class as well as. Okay, so here one we have an existing class and now you are going to write the new class. So new class can inherit the property or attributes and methods or feature behavior from an existing classes. So here new classes and existing classes. So in the terms of inheritance, you can say whatever the existing classes you have, we can say base class, parent class, or superclass. That means the existing classes which already have defined the attributes uh, and the methods, those known as a base class, or you can say parent class, or you can say superclass. Okay, and the new class which you're going to write, that is known as your derived class, or you can say child class, or you can say subclass. So these are three terminology we can use for the class which are inheriting the feature known as a derived class, or your child class, or you can say subclass. So overall, the objective of the inheritance is to promote reuse the code, and second, establish the natural hierarchy, or you can say relationship between the classes. Let's say we have a class A and class B. So with the help of inheritance we achieve two things. One things where you can make the relationship between the classes. If these two classes are related to each other, inheritance maker establish relationship between the classes. Second, also promote whatever the code here in the form of attribute, in the form of method, in the form of functions written, that can also reuse in the subclass or child class. So this is the fundamental about the inheritance. That is similar. The words also inherit. This is the come from the our real life example. Like if I am a parent, if I am a parent and I have a child, I have a child. My child have a rights to inherit some property, maybe my land, maybe my house, maybe my car, or whatever the property I have. This property by default inherited or get by my child. So similar, same concept in the object-oriented programming model. If one class already have some properties, and if you are going to make a relationship with the other classes, then other class is have a rights to inherit some code in the form of attributes or the behavior, or you can say methods. Excuse me. So let's think how we are going to write the code for the same. Okay. So here, first thing, let's we have a define any class, maybe superclass, superclass. Okay, and this is the superclass, and you can define the, you can say any attributes, maybe you can say define the attributes. Okay, okay. So generally, you can define a class. Here you can define some attributes, or you can define some method. Okay, or maybe super method. Okay, this is the something. Okay, that's just print. Okay, so this is a simple class, and till now, if I want to use this class, so you simply say, hey, super super class object. Just say super object equal to, and here you can use the super object dot call super. So in generally, we are just creating one class, and class have attributes, and class have some method, a super method. You can call this method. Okay. So till now there is no kind of inheritance. First, if you are going to make any relationship, so first we have to define one existing class. So this is my existing class. They have a one method, any method. Okay. So now how make a relationship. Here similarly, we have created simple one parent class, and parent class can define two name, first name and last name, two attributes we have defined. Okay, and we have defined one methods, print name, just printing the value. And how we can use this class, just creating the object of this class person, and we can invoke this function. Okay, till now the way we can create the class, we can create the object, and we can call the methods. Okay, so let's check how make our child class or subclass. So here I am going to define uh, class, subclass, class, and here simply say just define any attributes. Let's see attributes one. Okay, they have defined some attributes, and they have defined some methods. Okay, so till now here, notice there is simple two classes. One super class, they have some attributes, and they have some method. This is a subclass, they have some attributes, they have methods. So let us, I want to use this super method in this case. Let us open, uh, so let us, I want to just, let's, I want to just create the OBJ object of subclass. subclass. Okay, and here I pass many any attributes. Let's test. Okay, test, and notice from this subclass object, sub object, subclass object, sub object, we can invoke the sub method one. So from this class, I can only invoke this sub method. So is there any way I want to invoke this sub method? I want to use this method as well as. So is it possible? As of now, if let us I am trying to say, hey, this is my sub object, and can I call this a super method? Okay. So somehow till now this are not allowed because here say ki subclass object no have a attributes like a super method. That means there is no such method. So we have a two option. I can go and define this method again. So whatever the method here, I can go copy and I can go again test my subclass. Okay, maybe. So in this way, if it's working fine. So that means we are doing the copy paste. We are going to not reuse this code. We are going to the copy paste method. So here inheritance help us out. Don't do copy paste again. So instead of that, you can make a relationship between this subclass with the superclass. So how to make a relationship? Very simple way, just make a bracket and here you write a superclass name. So whenever you write this way, Python say now you become a class. Your this, your class, superclass, superclass, and this is a subclass make a relationship via this way. Whenever we specify subclass name and the class from where I want to inherit the value, so Python understand this is the relationship between two, and whatever the attribute defined here, method defined here, now it's available or inherited in a subclass, right? So if I again run this code, it's work fine. Now notice I have able to invoke from the subclass object. I can invoke the subclass method, even the superclass method also we can invoke. How it's possible? Because this superclass make an inheritance from sub. Even I want to access the attribute one something or attribute two. So let us. I want to access maybe here you can say comma attribute self dot attributes. So this is the super attribute, and let inside I want to access comma. This is your self attribute. Okay. Can I access this attribute? So here attribute one. Okay. And let us. I want to access here comma self attribute one as well. If you run, notice they are failing exception because subclass have a no attribute access. Reason that here we are able to this super method from the object, but inside the object you want to access this attribute one that is not defined here. So somehow it's possible. Yes. So let us we can take both attributes. So here I can say let's uh, attributes attributes, and here we can say I'm not giving a default value, just, and here say there is a concept of super, and you can initialize this attribute to the super, and here say hey, this is the super value. super value. This is the subclass value. Sub value. So here you can say whenever you're going to construct object, you can take this is the sub value, sub attributes, root, and this is the super attribute. Here you can pass super attributes. Here you can take sub attribute. Okay. So here you can initialize both, and here you can access. Now, if you run, notice still okay. Here is the okay. Here you can say self dot super sub attribute as well as the super uh, self dot slips. Okay. Here you can access the initialize the value. Notice is that from here you can invoke because this is the attribute accessed by this super method, and super method you can call from here. Here if you want to call the constructor, you can say call super initialization value, or even you can say super, you can call the super method as well. So in this way, you can access your super class, super value as well. So this super is a keyword you can say that help us to access super class attribute and super class methods. Right. So this is the way you can make a relationship between your super class with a sub. Right. So same thing here. We have a first one, the parent class, one parent class person, and person have a two attribute, first name and last name. Okay, and here you can go create another class student, and student inherit from the person. So here already have a first name, last name defined in the superclass, and in the subclass you can define an year as well. So here you can initialize this value to the superclass. Superclass initialize first name, last name, and in this year is the student itself graduation year you can define in the year. So in this way we can make a relationship between these two. So in short, you can say Python support inheritance with a very simple way, like just your subclass name, open, close curly brace, and specify the class, existing class, or you can say superclass from where you are going to inherit the code, methods, attributes. So let's talk about the type of inheritance. So in generally, inheritance is the object-oriented programming feature or concept, and that's almost all the programming language support, which are the object-oriented programming language. So Python also support couple of types of relationship like single inheritance, single label inheritance, multi-label inheritance, multiple inheritance, hierarchical inheritance, and the hybrid inheritance. Very simple way, single inheritance, that means a child class have a only one parent. That means we have a only one parent of the your inherited class. This is a child class. Child class have a only one parent. Means child class can inherit from the only one parent, that is known as a single inheritance. Multi-level inheritance, a class inherit from the inherit from a child class, which inherits from its another class. That means, let us this is the parent class inherit child class inherit the property, another maybe subclass also inherit the property. So parent class inherited by this child class also inherited by the grandchild class. So this is known as a multi-level. Maybe this class inherited by the another class. So this is known as a multi-level inheritance. Multiple inheritance means a child class inherit from the more than one parent. That means we have a one child, this is the one class child, and child class going to inherit property from the multiple parent, parent 1, parent 2, and parent 3. Okay, so here they can make an inheritance, they can make an inheritance. The multiple parents can be, this is known as a multi-level inheritance. That means one child class is inheriting properties method from the multiple classes. One is the hierarchical. That means we have a one parent class, and can have a multiple child as well as child one class, child two class, child three class. So this is known as your hierarchical uh, inter inheritance. So these are the mainly these four types of inheritance: singleton, multi-level, and multiple inheritance, and hierarchical. And sometime one more is the hybrid. That means maybe you can combine this both and make another inheritance. That means this is the one parent class have a two or more child class, and we have another class derived class, they can inherit from this both elements. So this known as a hybrid inheritance. So Python in the Python, in short, very simplest way, you can write or Python support all these five types of inheritance. So let us look one by one example so you will uh, understand very clearly how write this code. So single inheritance is a very simplest form of the inheritance, you can say, where just child class inherit from the only one parents. So let us look any example like okay. Let us class parents. A parent have a one method like p function, p method, parent method, parent method. Like let's we have another class child. So, and you want to see the child method, and this is the child. So here you make a relationship parent and child with the help of this. So now you make a relationship, and this is the simplest form of our child. From child you can invoke, you can maybe invoke a parent class method, maybe invoke child class method. So this is the simplest form of your invoking method. That means our child class can access the method of child class, or also can access the method of parent class. This is a simple single label inheritance because this child have a just only one parent. So this is the simple one parent class, one parent class, and they have only one child class. This is the only one child class. I make a relationship here. If one child have just only one parent, it is the known as a single label inheritance. And here our child class can get the access the math functions of your parent class and a function of it. Here child class can access the parent method, child class can access the child method itself. So similarly here example also another example given. One is the parent class name as a vehicle. Vehicle is a one parent class. A vehicle have a is a attribute brand and have a engine. Vehicle can be engine started. We have a child class. We have a child class. Child class is a car. Make a relationship with the vehicle. Means ki car is a vehicle. Here we have a car. We have a one class car. We have another class vehicle. Here you can say car is a vehicle. Here make a relationship between car and vehicle. So car have already defined car have a brand, and car have a engine function. Okay, so whenever I'm going to define my car class, in car class, just we can say car is driving. So here if I create my car class object, there is no any other function defined, only drive defined, so we can invoke the car drive. But even we can start the engine. So my car can start engine. So this method is inherited from my super class. This is the inherited from the vehicle class, because we are in this car, we are not defining a vehicle, even we can start the vehicle. Because why? Because car is inherited start engine function from the parent class. Similarly, one is your you can say multi-label inheritance. So what is the multi-label inheritance? So similarly, this is the parent and this is the child. Okay. Similarly, one more class. That's a class grandparent and grandparent have a grand. So here, this is my grandparent and grandparent make a relationship with the parent. So now this is the grandparent. Parent inherit property from the grandparents. Similarly, child inherit from the parent. So look like here a relationship came like this is your grandparent, this is your parent, and this is your child. So grandparent property are inherited by the parent, and parent property are inherited by the child. So this child class had property or behavior of its parent, and even they have a property of its grandparents as well. So here even I can call from a child class, we can invoke from the child class, we can access child method, we can access parent method, even we can access the grand method as well as. So our child class can inherit property or methods from the different label. That is known as a your multi-label inheritance. Means ki your child class does not have only one parent. The parent also have another. So this is known as a multi-label inheritance. So here same grandparent have a grandparent house, parents have a parents car, child have a bike. So whenever we are going to create the child class object, now child have a house as well as from the grandparents, and child have a car as well as from his parent, and child have a bike as well as. So these all properties child object can access. This is known as a multi-label inheritance. So let's talk about the multiple inheritance. Multiple inheritance say, hey, a class can inherit from more than one parent. That means we have a one class, they have already inherited some feature from the parent one, but they want to another feature from the different classes, maybe P2 classes, they can also. So Python support one class can have a multiple parents. That means कि from multiple parent classes, a child class can access the attributes. So this allows child class access attributes and method from all the other parent classes. Any number of parent classes can be. So many other programming languages like Java and other object-oriented programming languages not support this concept of multiple inheritance, but Python support multiple inheritance as well as. So let us example. So instead of here, let's new example. So here you can say class class one is the parent, one parent class. Okay, parent class have a parent display. Okay, and let's we have a let's father. Okay, father. We have a mother. We have a two classes. This is the father function. This is the mother function. Okay. Now we have another class like a child class child, and child have a function. So notice child class now have a two parents, father and mother. So they can inherit property from his father and also inherit property from his mother. So whenever you have a two classes and your child class can take the property. And now child equal to child, and from child you can invoke the from the child class we can access the function of the father and mother as well as. If you run, you can access both. Okay, and even so, let us here you can say I am even if you can access the child function as well as. Okay, so this is the way you can access. That means our child class. So here scenario comes like here we have a one class, we have another class, one is the your father, one is your mother, and another is child. So child is going to inherited property from father, inherited property from his mother. So now this child class have a both feature from his father, from his mother, and they have a own feature as well. So how to make this a relationship? So here's a child class. Just write, hey, this is my father and this is my mother. This is the way you can. Okay, this is known as your multiple inheritance. And here we have some kind of a confusion or problem if both have some common feature. So what happened? Let us. So what happened here? Have a another function like like uh, like a common. One is a common function. It is the common function. What happened? This common have a also in the is a child. So common have a this is from the this is from your father father and this is from your mother. Okay, and and now you can also same you have a so let us you can write in the child. Okay, so let's just comment out and here just you call p.com and it will run. So notice here say unintended. Where is the intention problem? So notice here now let us our this parent and this is. So notice here also one common function, here also common function, and let us this common want to access common function of father or mother. So here what I say, let us a super dot common. So question, this common function is come from this father class or mother class. Some programming language have this confusion, and due to that, so here the situation is that they have a two classes, and now I am going to call the function that's here also define if, here also define if, and I am calling this if. So question, this if is come from this root or this root. So something very clear. You can specify this is a father class, this is the mother class. I want to father. So just mention father, or you can just mention mother. This is simple way. So Python is the very simplest way to solve the problem. You can especially specify here, I want to father. You can say, hey, father.com. So they access the father.com. Okay, they access father comma. Uh, what is the what to say? This way. Let's say super.com and run it. So they are by default. Notice if you say super.common, by default Python say, hey, I am going to take the preferences the way order you mention. If you mention father first, by default they choose from father. If you change the order here, let's say I say cut here and I say mother first here, and if you run, it will check from the mother first. Okay, so this is the way order you can define. But somehow even you can specify, hey, no, you can also, I think, say no, I want a father.com, so it will come fathers only, even. Okay, nine. Or you want to mother, you can specify mother dot, it will get. So sometime if you are not specifying anything, by default Pythons get from the order you define, the first order taken by the by default. If you want to specify specific, no, I want to father, so you can mention the father then common function, or mother then common function. This way ambiguity can be avoided in the Python. But sometime this is the confusion key, which class or method invoke common from this parent 1 or parent 2. So this is solved from this order of inheritance, the way you can define here, or you can specifically mention this parent class I want to call this common function. So this is known as a multiple inheritance. So similar here, this is your father class. Father class have a skill gardening. This is your mother class, have a skill cooking. These are two separate classes. You can create one child classes. And child classes is going to make a relationship from his father, and also going to make his relationship from his mother. So here is the multi-level inheritance. And now here you can access even the father or even the mother skill, because the skill is the common uh, behavior between the different parents. Okay, so let's next is the very realistic, you can say, in our really uh, one parent one parent can have a many child 1 and child 2, child 1 child 2. This is the simplest way. As well as you can create one parent, and parent have a child 1 and child 2. So here child, this child can inherit the property of this, or this child also inherit the property of parent. So this is a very known as your hierarchical. Even this have a some child, they have a also some child, they have a, so this property can inherited here, a same property can inherited here. So this is known as a hierarchical inheritance. Okay, so this is also very simplest form of your parent and child relations. Okay, so class parent, parent, parent have a parent capability, and now let us we have a one child. See the child, and this is the child behavior child, child, child. Let's say this is the child 1, and similarly let's say the child 2, child. So how make a relationship? Just make here the relationship parents, the relationship parent. So both child have a same parents. Now in the child 1, equal to this, and you can invoke parent capability, right? So from child 1 we can invoke parent. Even the child 2 also invoke the parent property, invoke the parent property. So this is the way make your hierarchical kind of relationship. We have only one parent, but can have a child 1, can have a child 2, and both are, this is the behavior. Parent display method can be accessed by child 1 and can be accessed by the child 2. If any more child also can access the inheritance. So sometime we make a hybrid. So here make a hybrid. Hybrid is not any kind of a new types of inheritance. Simply say we can combine any one of four, maybe level, multi-level, or multiple, yeah, hierarchical inheritance. So here, for example, we have a class A. This is the class A. We have a class B. Class B. Class B make a relationship with the A, and we have a class C. Class C, here is the class C also make a relationship with the B. So now this is the your hierarchical relationship. It is one parent have a multiple child. Now we are going to create another class D that's inherited from the both B and C. Here inherited from the B and inherited from the C. So notice, if you be carefully look this is your multiple inheritance. Means ki one child class have a multiple parent. Here on the top level you can say this is kind of a one parent and multiple child, and you combine both, this is become a hybrid inheritance. Okay, where you can combining the multi-level plus your multiple inheritance. So this is the situation where you can solve the hybrid. And here one common situation or a problem occur whenever we are a hybrid multiple inheritance. What this is known as a sometime known as a very common problem is the, let's example. So here say, let us you can say same class A, okay, and here simply define a methods and things. Okay, so just say, and now we have a two classes, class B, we have a B method. Similarly, when we have another class C, also inherit from the C method. So we have a class A, class B, class C. A have a child, B and C. Now let us write a class D, and D are going to inherit from the A. Okay. So let us, here is the very good. So now we have say D equal to D and call the method say, and let's print. Here you, so notice here what we did here, let us here make class A, and they have a one function defined like a method. Now they have a two subclasses B and C. They inherited here, they inherited here. Now we have a class D, D inherited from here, D inherited from here. So the question here of the D, I am going to invoke the A method. This A method inherited come from this root via B, or this come from via C. So this is a sometime known as a inheritance diamond problem. So here, due to this situation, other programming language like Java does not support the multiple inheritance, because this is the confusion for this class. They are going to inherit because this is the common function f defined here. They are available here also, they are available here also. And if I am going to the call this f function here, this f function come from B or come from C. So by default, the Pythons is given the solution is the order you can define. If you are given a B here, they are come from the B by default. If you want to from the C, you can specify mention I want to C. So with the help of order which Python here defined, due to that they are very easily solve this problem. There is no confusion at the compiler level. Compiler mention if D class have a 2 B and C, which order you can specify. You will specify B. So I am going to the follow B route. From the B class, I am going to inherit it from this. The simplest way, this diamond problem of the inheritance issue can be addressed by the Python, and this is the way you can access this uh, so drive class or D class can access the function from the A class. Okay. So this is the types of inheritance you can say supported in the Python. Single level, multiple level, single level or multi-level, and you can say multiple and hierarchical and hybrid. Okay. As single level, that means simply this is the one child class have just only one parent. Okay. And in the case of multiple, one child have a multiple parents. So this is the one child can have a multiple parent. This is the multiple inheritance. Multi-level, that means A class can inherited by the B class, can inherited by the C class. This is the your multi-level. Hierarchical, one parent class can have a multiple child class. This is your hierarchical. And hybrid, you can just combine any two. Maybe just this is the one parent class, they have a two child class. This is your hierarchical, and this two parent class just combine with one child class. This is a become a your kind of hybrid inheritance. So, in short, Python's very simple way support all types of inheritance, maybe single level, or multi-level, or multiple, yeah, hierarchical, or you can say hybrid. All types of inheritance, very simplest way we can implement in the Python. Python have one more concept related to the inheritance known as a polymorphism. So here, situation, if let us we have one class and they are overridden by the class A and class B. Here I can define one function. Okay. This function inherited come here. What happened? I again define the same function here. Same function also defined here. So this is a concept known as a polymorphism. Polymorphism say is the many form. This one function can behave. This is the object oriented again. Polymorphism is also one of the key concept in the object oriented programming, and it allow the same method name to behave differently based on the object assigned. So here, if notice, this is the f function. If I am defining my function, they are, let us call this function. Let's call this function. Okay, so this function, whatever the object dot invoke function. So here, let us we receive this object as an input. Okay, so this object that functions, I cannot say that these are going to invoke the definition from class A or class B at a compile time. That compile time we cannot define the what is the exact behavior of this f function. If what the object you pass, if the you pass the object of A here, this means you are going to call the A behavior. If you pass the object of B here, they call the B behavior. This is known as a one behavior can play a different role. Can This is known as a polymorphism. One function have a many forms. And in a Python also, you can say two main types of polymorphism. One is the compile times, another is the runtime. So some functions we can exactly identify at the compile time. Some function we can know and define at the runtime. So runtime known as a your method overriding, and uh, compile time is known as a method overloading. So you can say Python support polymorphism, and the polymorphism can be at a runtime. Means at a runtime we can identify the behavior of my function. Compile time polymorphism, that means we know at the compile time this function invoke the this definition. So let us take the example. Method overloading is the runtime polymorphism. What do you mean? Whenever a child class provide a specific implementation of method that is already defined in its parent class. That means we have a one parent class have defined one function, and the same function I can go and redefine in my child class. Same function if I define. But this is known as your method overriding. That means the child class going to customize or completely replace the behavior of inherited method. So whatever the business logic written in this parent class of this function, maybe we can going to give the new definition. A new definition maybe modify something, or completely new definition depend upon the override. If I'm not defining this function here, that means this is the by default inherited come from the superclass. But when you define the same function inside the subclass, that means this function is the overridden. That means whatever the definition given here, this is the going to nullify and new definition given for this subclass. So whenever this class function invoke, the new definition will come. Whenever this class function invoke, the old definition will call. Okay. So let us what happened? Okay. So let us call. It's okay. So question, the situation, why we use override? Well, first things, customize the behavior, inherited method behavior in the child class. Whatever the methods we are inherited from the parent class, we need sometime customized behavior, a change behavior, okay? And also sometime to extend the functionality of the parent class. I have a maybe parent class function have a limited logics, and I can just redefine with some behavior and add more function. We can extend the functionality or completely change the behavior. In those situations, we are overriding the method. And to implement the this polymer vision, what we do? Where the same method behavior differently depend upon their order. That means this same function, whatever the function we define, the behavior is completely different depend upon the which object we are going to call this function. So let's talk about the implementation. Okay, how we can call this. Okay, so let us same example here given. I am just right. Let us we have a class employee. Okay? Employee. Employee have a simply one function. Let's say same work. Okay? Employee is working maybe working from any types. Okay. So now let us we have a two more class. One is the employee, another we have a let us developer. Developer. Okay. Developer. Okay. And similarly, let's one more class we have a known as a some UX designer. UX designer. UX designer. Okay. So notice now we have a one employee class, and employee class is working. Similar developer is also working UX designer. So let us we are defining the one polymorphism here. So let us office. We are going to defining a function maybe office work. Office work. Okay. This one. You can just say. Okay. So question here. So this is our employee.work. Here we have a one employee cell, one have a developer employee, one have a UX designer. So this work function is how to define. So let us someone going to call this office work, and let us we have a what we have a developer, one have a UX designer, we have a two. If I pass here our developer, this function work for the developer one. Run, this is for the developer. So if someone looking this code, they are not know okay, this is the output of this is the developer is working, employee is working, or UX designer. If I pass no, I pass the UX designer. So this same of work is working for their. So this work function is behave differently depend upon which types of employee I pass. If I pass this employee is the simple developer or UX designer or any other types of. Okay. So here is the completely implementation of your. So here what we did, here we have a simply one employee. We have a one employee, but in our organization, employee can be different types of employee. Maybe you're a developer, maybe you're a UX designer, maybe you're a tester, right? Now different types of employee. And today, just if someone which are working office work, let's say this is my function and pass the employee object, and it can say employee dot work. Okay, this is the employee work. This function employee work. At the run times, we cannot say the what is the output of this work. This work is for this class, for this class, or for this class. Okay, so this is the runtime polymer. This if I here pass the developer object, this work for the developer. If I pass US designer here, it's work for the US designer. This is known as a method. This method is overridden in this subclass. So here we have defined the work. Work is the overridden in the developer, work is overridden in the US here. So which object pass accordingly this work function work. So similarly here, the example mention, this is our employee working from 9 to 5, developer write code, UX designer design UX. So here we have a one employee, but they have a two implementation. One is the developer part, one is the UX designer. And whenever they are going to call in office work, so office day, maybe employee one, then this is the behave dynamically. So this is known as a runtime polymorphism, yeah, overriding. Okay. Similarly, one more concept is overloading. Overloading simply say allow this is known as a compile time polymorphism, and it's allow we can define or you can a class can have a more than one method with the same name. Is it allow? Yes, it's allow, but with some condition. Condition the function parameter must be different. If this is the types for integer, it must be maybe for the float or double. Or maybe this is the if they have a one argument, second function must be yeah some different argument. So this is the way known as a method overloading. Whenever object you call some method and the same method you can call with a different parameter, that is known as a method overloading. This is known as a compile time polymorphism. So let us look the example. So let us look the example. Class let's calculates. Let us define add and here okay. So let us a comma b and here print. Okay, simple function. Okay, so if let's I say calculate equal to calculate and calculate dot add 1 comma 2. If I run, it's print 3. So is it possible we can call this add function 1 comma 2 comma 3? If run, it says no, you cannot call the same function with a different parameter. You can say yes, we can. So here say you can say hey, let's see C, and here you can say plus C. Okay. Okay, and if you run, notice again fail. If this at this time not works, at this time not works. So how I can say it both can work? So there is a concept here. Maybe multiple we can define the different function with a name, or you can say just with the default value. Maybe default value 0, maybe default value 0, maybe default value. Okay. So here default value 0. Give some default value. And in this way, if you notice, this is also works. Run, it works for 3. Even if you want to make a one argument, it's also work. Even you want to zero argument, even it works. So notice someone looked this class, even the add function called 0 argument, 1 argument, 2 argument, 3 argument. This is add method is overloaded. That means we can invoke from the one object the add function in the different form. So this is the one-way implementation. Even we can implement maybe 4 arguments. Then again, so best way instead of writing with the default value, simply you can say that's another function. So here say let's sum. And instead of this multiple default value, this is the concept of your multi-argument value. Okay, and here you can simply now this receive all the arrays value, and now you can just use the sum function and argument sum, and now even here you can do the sum. C dot sum, and here you can pass any number of argument, still it's works. Even you pass two argument, three argument, okay, even 10 argument, still it's works. Okay, so in this way you can notice we can defining a sum function with a multiple way we can call. So this is known as a method overloading. So Python support you can write a method overloading and method overriding in the both way. So be ensure that whenever you are going to invoke the overloaded function, our Python interpreter identify show your variable length and type. So if we have a one argument function integer, here again you call this f one with the same, so it's not, it must be same different type. Maybe this is the float value, this is the integer value, one argument float value, it's work fine. So please ensure that method overloading a parameter is defined the number of argument, variable length, number of argument, one argument, two argument, three argument. If argument differ, the different. Or if the argument is same, let's the two argument. Another function two argument. The type also must be different. If it is the integer, this is the float. You can say float and integer in a different order. You can say the number of argument, the types, and the order of the type. If all these three are in the different order, that times you can say overloading. So these are the same example I explained. Like here you can call the add two function, add with a three, add with a no argument. Here add with a two argument, three argument, five argument, any number. A different way you can provide the implementation of method overloading. So that is uh, the point which I want to convey for the inheritance. So you can say Python support inheritance. That means whenever we have a class, existing class have some attribute and property behavior, and I am going to write a new class, so I can reuse this code here if you want. So make a code reusability from the inheritance, and even you want to make some logical relationship between the classes inheritance offer. So inheritance have a five types of inheritance. Your single level of inheritance, that means one child and one parent. Multi-level means ki one parent have a child, have a child, have a child. This is the multi-level. Or you can say one parent have a multiple child. This is the hierarchical inheritance. Or maybe multiple child can have a one one child can inherit from the multiple, and the hybrid combine this hierarchical inheritance combined with a multiple inheritance. This become a hybrid. So this is the type 1 single level, type 2 multi-level, type 3 hierarchical, type 4 multiple inheritance, type 5 hybrid. So Python support all these five types of inheritance. And while inheriting, if you have defined some function here, similar function you can define here, this function known as a method overriding. And our last concept to discuss, method overloading. You can define one function and similar function you can define with a different argument. So that is the method overloading, and method overriding is the concept come under your polymorphism. So these are the 2 points we have for the day today. We can understand the inheritance concept and example, similarly polymorphism. So if you want to get more understanding, or if you want to become some more confidence, so you just write some types of inheritance, some code, and play with the code. Once you play with the code, this concept inheritance and polymorphism is very very simple and important. Whenever we are going to build your applications, this polymorphism and the inheritance are heavily used in the real application. So make practice, do exercise, and feel comfortable the concept of inheritance and polymorphism in in the Pythons. So that is for the day, and I hope this information is helpful for you.